What's up guys, and welcome to this video. Okay, so this video is on mechanical energy and the conservation of mechanical energy. It's usually a really nice section. The questions aren't too hard. Fundamentally, there's not much thinking that happens, as in they all have to do with the same thing, and it's basically a process. And if you understand the process and understand what you're doing, then you can easily get the marks. Okay, so as per usual, we'd start off any section with some definitions. So what is gravitational potential energy? So gravitational potential energy is the energy that an object possesses due to its position relative to a reference point. Okay, so our formula for potential energy is denoted EP. So the potential energy is equal to mgh, where m is your mass, g is your gravitational acceleration, and h is your height. Okay, so basically what this tells you is that if we have some object, let's say with a mass of 2 kilograms, and it's some height above the ground, then this object has some form of energy, some stored energy, okay, some potential energy. So if I move this table, then the mass will fall. So obviously it has to have some energy that it's storing. Okay, and that energy is due to its height above the reference point. So let's say the bottom is our reference point. Okay, and with energy, we have units of joules, as per usual. Okay, then we have kinetic energy, which I hope you guys have come across before. So kinetic energy is the energy that an object has as a result of the object's motion. Okay, so I'm sure most of you know this. It's basically the energy that an object has because it's moving. Okay, and we denote kinetic energy EK is equal to a half mv squared, where m is your mass and v is your velocity. Okay, and again it is units of joules because it's also energy. Okay, then we have mechanical energy. So the definition for mechanical energy is the sum of the, I'm just going to say, of the gravitational potential energy EP and the kinetic energy EK of a body at a point. Okay, so the equation mechanical energy, we denote that Emech, or the mechanical energy, MECH, is equal to EP plus EK. Okay, so not too difficult there, and again units of joules. Okay, then we have conservation of mechanical energy. Okay, so conservation of mechanical energy, the definition is in the absence of air resistance or any external forces, the mechanical energy, so the mechanical energy of an object is conserved or is constant. Okay, so basically what this saying is, if there's no air resistance or external forces such as friction or something like that, then the Emech of the system remains the same across its motion. Okay, so basically let's get straight into an example. So those are the equations you really need to use. There's 3 of them, 1, 2, and 3. With those you can usually do any question. Okay, so let's go for this question. Okay, so basically to summarize the question, it says ignore air resistance. We have a building which is 15 meters high, and we have some mass of 150 kilograms at the top, and basically this mass is falling all the way to the bottom. Okay, so this is the top of the building and this is the bottom. Okay, when it's at the top, we know that the velocity is equal to 0. It's not moving, and when it's bottom, we're using the height from the bottom. So this is our reference point. Okay, so everything, our EP is measured according to the reference point. Okay, cool stuff. So we can go straight into question. It says the potential energy. So calculate the potential energy at the top of the building. So we know that EP is equal to mgh, which is equal to our mass, which was 150 kilograms, times gravity, which is 9.81, times our height, which was 15 meters. And if we plug that into our calculator, let's see what we get. We get 22,072.5 and units of joules. Okay, then it says calculate the kinetic energy at the bottom of the building. Okay, so in this case, we've been told that we can ignore air resistance, so I'm going to use the conservation of mechanical energy. So what I'm going to say is that my EMAC, my mechanical energy at the top of the building, must be equal to my mechanical energy at the bottom of the building. So we know that EMAC is equal to EP at the top, so the potential energy at the top plus the kinetic energy at the top must be equal to my potential energy at the bottom plus my kinetic energy at the bottom. Okay, so at the top of the building, we already discussed that the whatever's at the top, this mass is not moving, so obviously its kinetic energy must go to 0 because velocity is equal to 0. Then at the bottom, we spoke that the reference is at the bottom, so this is 0, so height is equal to 0 at the reference point. At the reference height is equal to 0 at the bottom. So we know that our EP at the bottom also goes to 0 because height is equal to 0. Okay, so what we're left with is that EP at the top, our potential energy at the top, is equal to our kinetic energy at the bottom. So what we have is we already calculated the EP at the top of the building. So EK at the bottom is equal to EP at the top, which was 22,072.5 joules. And that's our answer. Okay, calculate the velocity at the bottom. Okay, we already know EK at the bottom is equal to a half times the mass times velocity squared, which we calculated as 22,072.5 joules. So we can say mass is equal to, what was it, 150 kilograms, yep, 150 kilograms. So solving for V, let's put that into our calculator, square root the answer, and we're left with 17.16 meters per second, and we want velocity, which is a vector, so at the bottom we know it is going downwards. Okay, and the last question here is a proof that says prove that the velocity of an object falling from some height h is independent of the mass of the object. So we want to prove that the velocity at the bottom is independent of the mass. So again, we're going to go with our mechanical energy at the bottom is equal to our mechanical energy at the top. So we have EP bottom plus EK bottom is equal to EP top plus EK top. Okay, and as we discussed before, the potential energy at the bottom is equal to 0, and the kinetic energy at the top is equal to 0. So we have EK at the bottom is equal to EP at the top. So what's our formula for EK? It's a half mv squared, which is equal to EP at the top, which is mgh. Our masses cancel, so we're left with V is equal to V squared equals 2gh. So V is equal to the square root of 2gh. So V is, so we can say therefore V is independent of mass. Okay, so basically what we're saying is that if we had another object, that was, let's say, 75 kilograms, and we dropped it, as long as it's from the same height, the velocity of the 15 kilogram block is equal to the velocity of the 75 kilogram block is the same as the velocity of the 150 kilogram block. Okay, so let's actually, so basically that's what we've proved, that velocity is independent of mass. So we can do one more question, I think, actually. So let's do another question. I think questions we did in green for some reason. Okay, so we will do question 2. Okay, so question 2 is a nice fun question. So we have a roller coaster. Okay, so that's our roller coaster, and we have a cart. Okay, so let's define some heights. Okay, so this is the bottom of the roller coaster, and we have this height right here, which is 12 meters, this height right here, which is 6 meters, and this height right here, which is 10 meters. Okay, and what we have is, we can say this is point 1, this is point 2, this is point 3, and this, which is in line with point 1, is point 4. Okay, so point 1 and 4 are on the equal height. That can't be 10, let's say that is 20 meters. Okay, so we've got this, let's say the mass of this cart, mass m, is equal to, let's say, 150 kilograms once again, and we can say assume no friction, and let's actually put this mass right here by 1, so we have our mass right here. This is point 1, and we can say it starts to move at point 1, so cart starts to move, to just move at point 1. Okay, so question A is, let's say, calculate the gravitational potential energy, EP, at point 1. Okay, so if we did that, we're going to say EP equals mgh, which is equal to our mass of 150 times 9,8 times our height, which is 12 meters at point 1. So if you plug that into our calculator, we get a value of, let's see, 17,640 units of joules. Okay, so what is the kinetic energy when it reaches point B? So let's say for question B, what is EK at point 2? Okay, so we know we can do the whole conservation of mechanical energy, but we know that it's lost all of its potential energy here. So EK, let's do it in red, EP at 1 is equal, okay, let's say EK at 2 is equal to EP at 1. Okay, and you can go prove that to yourself if you want, and we can say it's 17,640 joules. Okay, so calculate the velocity. So question C is going to say calculate the velocity at point 3. Okay, so we're going to use conservation of mechanical energy here. So I'm going to say Emech at 1 is equal to Emech at 3. So EP1 plus EK1 is equal to EP3 plus EK1. Okay, so EP1 is equal to mgh1. Okay, so I will say this is h1 and this is h3. Okay, EK1 is equal to 0. Okay, at the top it just starts to move, so we can say the velocity at the top is equal to 0, is equal to EP3, so mgh3 plus EK1, EK3, which is a half times the mass times the velocity at 3 squared. and that's what we're looking for. We're looking for this quantity right here. So we can actually take out the masses. So we can say that if we rearrange this, this is going to come out as v cubed equals the square root of 2g h1 minus h3. Okay, and that is the same as this equation right here that we solved for, where this is just change in h now. Okay, so if we plug in some values, we can say that v3 is, let's see, square root of 2 times 9.8 times my height 1 minus my height 3. So height 1 was 12 minus 6. Okay, and if we plug that into a calculator, we get a velocity of 10,85 meters per second. I'm actually going to say speed because we don't care about direction. Okay, then the next question would be D, is what is the velocity at point 4? Okay, so let's think about this, right? So basically we are at the same height as point 1. So the velocity at point 1 equals 0, so v1 equals 0. When it gets to point 4, v4, it's going to have the same velocity because it's the same height above the ground. So it's going to be equal to 0 as well. So we can say that v4 velocity at 4 is equal to 0 meters per second. If you don't believe me, then go ahead and do our conservation of mechanical energy once again, and you should get that answer. Okay, and then just a conceptual problem. So let's just think about this, and will the cart ever actually get to point 4? Probably not, and the reason is there is probably some kind of friction on this surface in reality. So if this was a real world system, the cart would probably never get to point 4, it would probably end somewhere here due to friction. Okay, so that's also something to just keep in mind. Okay, so in the next video, so I'm going to call this the end of this video. In the next video, we will continue with some more questions, just maybe 1 or 2 more questions. Yeah, so thanks for watching, guys, and after that I will go into momentum and impulse and stuff like that. So thanks for watching. I hope you found this useful. Cheers.